Hey everybody, we are still in section 2 of chapter 1. We are doing applications and modeling with linear equations. We are moving on to some motion problems. By motion problems, we mean that we are covering some sort of a distance. Sometimes that distance is not a literal distance, but maybe it's how many widgets your company creates or something of that nature. It's a distance is an accomplishment, but it will still follow the classic formula that people should be pretty comfortable using, which is distance equals rate times time, right? I used to remember that one because it kind of looks like the word dirt. But another way, and probably a better way to think of it, is I know what a rate is. A rate is a speed. And an example of a speed is something like miles per hour. Miles is a distance, per is the slash, like a division, hour is time. So these are actually both the same equation. If I wanted to solve for r in the first equation, I could divide both sides by t and I get r equals d over t. So whatever way you remember it, just remember that these equations are not always just handed to you. It's really your responsibility to remember them, okay? Now, Maria and Eduardo are traveling to a business conference. The trip takes 2 hours for Maria. Okay, already as I'm reading, I'm already seeing stuff going on here, right? And what is it that I'm noticing? Well, I'm probably going to have to analyze the difference between Maria's trip and Eduardo's trip. So I'm going to basically think of it in two separate setups. So I'm going to have pink, distance equals rate times time for Maria. And I will have green, distance equals rate times time for Eduardo. Okay, so each of them will have kind of their own little setup, and we're probably going to do some comparing. Okay, so the trip takes 2 hours for Maria, and that seems to be like a locked in fact, right? So Maria, the time without a doubt is 2 hours. And Eduardo, the time seems to be without a doubt 2.5 hours. Now, the math nerd in me would rather change that 2.5 into 5 over 2, an improper fraction, because it'll probably clean up a little nicer, but I'll leave it. I'll practice self-control. So that is the time. So I'm even going to kind of highlight a little bit. So time 2.5, and takes 2 hours for Maria and 2.5 hours for Eduardo. That's where all that information just came from. So if anyone's confused. And it took longer because he lives 40 miles farther away. All right, so now we have some more going on. What we have going on is that the distance that Maria lives, okay, the distance that Maria travels can be just distance, okay? That's Maria's distance. But Eduardo's distance, right? Eduardo's distance is related to Maria's distance because it equals Maria's distance plus 40. Whatever Maria's distance is, plus 40 is Eduardo's distance. All right. So that is the difference right there. He lives 40 miles farther away, right there. Farther away than Maria. Okay. Next. That's distance. There's an equal sign. There's an equal sign. I don't have rate in either case right now. All right, let's see what is next. Why do I feel like I already know I'm not going to have enough room. So let me just 2.5 move that over a bit. 2.5. Let's put that right there. So all I'm doing is getting the facts down, but I'm keeping them separate because the trip is different for both Maria and Eduardo. So, side by side. Eduardo travels 5 miles per hour faster than Maria. Find their average rates. Okay, now earlier I mentioned writing a let statement. So we're going to let D equal Maria's, am I on the screen? Yes, distance. That's one thing. And let R equal Maria's, so Maria's the star of this over here, Maria's rate. or speed, whatever you want to call it. So Maria traveled R miles per hour, whatever that may be. Do I know what it is? Nope, but we'll figure this all out. Now, that means Eduardo, he traveled 5 miles per hour faster than Maria. So whatever Maria's rate is, he's traveling that plus 5. 5 miles per hour faster than Maria. Like that. Then okay, and then here also he lives further away than Maria, right? Now, I have two different equations. Distance equals rate times 2, which obviously we can clean Maria's equation up a bit. We can just write distance equals 2r. And I have distance plus 40 equals r plus 5 times 2.5. Maybe you clean that up a little. D plus 40 equals, and maybe you put the 2.5 in front because that's how you like, writing your distribution kind of stuff. Okay, so I have two equations and I have two variables, but that's perfect. If you have two unknowns and two equations, that's all you need. We can solve by using some substitution. If this right here, 2r, is equal to Maria's distance, I can go ahead and fill that in for D because D is right over here. I'm going to use a little substitution move. So that means 2r plus 40 equals 2.5. I'm going to start distributing on the right. R plus, what's 2.5 times 5? Well, 2.5 times 10 is 25. But then instead of times 10, I'm doing times 5. So I really want half of 25. And that's going to be 12.5. So plus 12.5. Okay. So I'm going to go ahead and continue to solve. That means, let's see, I'm going to subtract. I'm going to bring 2r to the right side. So, because I don't want to have negative, So that means I have 0.5r here. And I'm going to subtract 12.5 from both sides. So 40 minus 12 is 30. Minus 2 is 28. Minus 0.5 is 27.5 right there. Now, 0.5 is ugly type or ugly talk or ugly writing for 1/2. How do I get rid of the 1/2? Well, I multiply both sides by 2. 2 and 1/2 reduce out. And let's just go here. I'm left with R, which is Maria's rate, equals 2 times 27.5. 2 times 20 is 40. 2 times 7.5 is 15. 40 and 15 is 55. So Maria drove 55 miles per hour. That's her average rate. Does that mean she drove that the whole time? No, but that means she averaged a pacing of 55 miles per hour. And then Eduardo, good old Ed, will be at what speed or what rate? 60 miles per hour because he was 5 miles per hour faster. So find their average rates. Done and done. So we're going to highlight our final answer. Let's get a nice light color. How about that? There you go. And that's it. Hopefully that made some sense. When I did this another time, I definitely cleared out my decimals right away because I had that 2.5 written as 5/2 and I multiplied everything by 2 earlier. And I just got to avoid the decimals and the fractions throughout the entire problem. But I kind of felt like a lot of people that maybe tried this on their own probably did it by maybe leaving it. So I wanted to finish working it out that way. Hopefully that made sense to you. I tried to do it in the most organic way possible, something that will stay with you and not something that you'll memorize for short term. I want it to be a way of life that you understand the relationship between distance, rate, and time, and how to write your own expressions and how to kind of reverse engineer stuff and figure it out. So there you go. If that worked out nicely for you, go ahead, give Ghosty over here a nice thumbs up. If not, thumbs down, questions, comments, concerns, whatever it is in the comment section below. There should be a playlist popping up on the screen, and you could go ahead and check on that playlist and see if you could find more of whatever it is you're looking for. And that's it for now. Sayonara.